For billions of years, Earth's oldest continental crust seemed indestructible. These ancient formations, called cratons, were thought to be permanent fixtures on our planet, too cold, too thick, and too strong for anything to break them apart. Scientists just discovered they were wrong. A groundbreaking study led by Professor Xiaofeng Liu at the China University of Geosciences reveals that even Earth's most ancient continental crust can slowly disintegrate when tectonic forces change direction and intensity. The research focused on the North China Craton, a massive continental block that once spanned nearly 500,000 square miles and contained rocks older than 2.5 billion years. This geological giant had roots extending more than 120 miles deep into the Earth. But during the late Jurassic period, something extraordinary happened. The craton collided with the Izanagi oceanic plate, creating an unusual flat-slab subduction zone that stretched horizontally beneath the continent for thousands of miles. Using advanced four-dimensional mantle flow models, Liu's team recreated 200 million years of geological history. They discovered that this flat subduction initially compressed and thickened the continental crust by roughly 54%, creating mountains and elevated terrain. Then, 136 million years ago, the tectonic script flipped. The oceanic slab began rolling back toward the ocean trench, creating a negative pressure zone that allowed hot mantle material to rise and weaken the craton's deep roots. The results were dramatic. Seismic studies show that eastern North China's lithosphere is now less than 75 miles thick, barely half its original thickness. The supposedly permanent geological foundation had been torn apart from below. This discovery isn't isolated to China. Similar processes occurred beneath North America's Rocky Mountains and South America's Andes, suggesting that proximity to active tectonic margins, not age, determines a craton's fate. The implications extend far beyond geology. Destroying these deep roots can relocate volcanic activity, alter mineral deposits of copper and gold, and even change surface elevations by thousands of feet over millions of years. This research, published in Nature Geoscience, fundamentally changes our understanding of continental evolution. Even Earth's most ancient and stable formations are works in progress, constantly shaped by the dynamic forces beneath our feet. For more on this story, find a link to the article on Earth.com in the description.